it's still an important preparation for the final exam. Okay, one of the problems is an easy antiderivative problem. That's problem 3, where you have to find the position of an object. And you have given the velocity. And you have given the acceleration. And now you have to go backwards. So if you have given the derivative of the velocity, the rate of change of the velocity, which is called acceleration, as minus 6t plus 6, what is then the antiderivative of minus 6t plus 6? This is then the same as minus 3t squared plus 6t plus a constant. And now the question is, what is the constant? But the constant you choose now, you know that v of 0 is equal to 0. So when we plug in for t equal to 0, you should get 0. So c must be 0. Yeah, if the initial velocity would have been 10, then you have to add 10, then it's minus 3t squared plus 6t plus 10. And now we have to find the position. The position is the antiderivative of velocity. So if you take the antiderivative of minus 3t squared plus 6t, then you get minus t to the 3 plus 3t squared plus a constant. But since the position at 0 is 0, the constant must also be 0. So you get minus t to the 3 plus 3t squared. So that is part 1. So you have to, you found now the position of the object. And now you have to find the maximum, and the minimum of the position for t between 0 and 5. Now,
It's 5.
Now what in the world was that? I'm getting old. So he was just talking to me. So you have to find the maximum and the minimum of this. So the easiest way maybe is to take a calculator and look at the graph on the calculator. Or the maximum or minimum is where the derivative is equal to 0. So if this is equal to minus 3t squared plus 6t, which is then equal to 3t times minus t plus 2. And this is equal to 0. Now you make the first derivative test from 0 to 5. And you have at t equal to 2, you have a critical point. And if you plug in a number between 0 and 2 in the first derivative, then you have a positive number. And if you plug in a number greater than 2 in the first derivative, you have a negative number. So you get a maximum at t equal to 2, and you have local minima at t equal to 0 and 5. So you have maximal positions if t is equal to 2. Then you have s at 2 equal to minus 8 plus 12, which is equal to 4. So that is your maximum, and the minimum at t equal to 0, where s of 0 is 0, and t equal to 5, where s of 5 is equal to minus 125 plus 75, which is minus 50. So there you have your local minima, and this is your maximum. So that is the solution of problem 3. It's a position, velocity, acceleration problem, where the only thing you really have to know is how they are connected, that velocity is the derivative of position and acceleration is the derivative of velocity. Okay, now U substitution. And for this I do now some of the problems I have mailed out yesterday. And the first one would be the integral from 0 to 10 of 1 plus 5x to the 201 dx. Now that's a problem. If you try to do this on your calculator, you will not get a result, so you really have to do it with U substitution. And the U substitution there is you pick U equal to 1 plus 5x. I think that's the only reasonable choice in this case. Then you have du dx is equal to 5, or 1/5 du is equal to dx. And you could change, you could solve for x, then x is the same as u minus 1/5. But this is something we will not need at this point. So these are the 3 steps for U substitution. And now if you substitute it in, then you get what? X ranges from 0 to 10. So U ranges from 1, if x is 0, and x is 10 to 51. 1 plus 5x is U. And dx is 1/5 du. So if I put this information into this integral, I get this. And now you are done. If you take the antiderivative, you get u to the 202. You have to multiply with the reciprocal. And there you plug in 1 and 51. So it's 1/1010 of 51 to the 202 minus, if you plug in 1, 1/1010. If you want, you can simplify this, but this is not necessary. Okay, so that's the first problem. Second problem, antiderivative. of sine x over 1 minus cosine x dx. And it's always a good strategy to try to rewrite this, in this case, as sine x times 1 minus cosine x to the minus 1 dx. So sometimes that's important, sometimes this is distracting, and this is what practice is for. Because now the choice is the u. And one of the rules is that you always pick as u where you also see the u prime. So if I pick the u to be 1 minus cosine x, then du dx is equal to sine x. In the sine x, I see here, in fact, I see sine x dx. So these are my two choices of u. If I plug this in, then it's the integral of sine x dx is u. Which is then the same as the logarithm of u plus a constant. So it will be the logarithm of 1 minus cosine x plus a constant. Next problem, huh? Now, the question is, what do you do first? And the answer is, you always look first you always try to simplify your integral. So in this case here, in our first problem, there's really nothing much you can simplify. If you multiply out 1 plus 5x to 201, you will be busy for the next 2 or 3 weeks. Also in this thing here, there is really not much you can simplify. There is nothing much you can divide. But in this case, you can really simplify it, because if you divide by e to the x, then you have the integral of 3 plus 2 over e to the x dx, which is the integral of 3 plus 2 e to the minus x dx. So in this case, you really don't need a u substitution or anything here. You just have to know that the antiderivative of e to the ab, e to the ax is 1 over a e to the ax. So the antiderivative of 3 will be 3x, and then the antiderivative 2e to the minus x will be minus 2e to the minus x plus a constant. Yeah, check if I take the derivative of 3x is equal to 3, and the derivative of minus 2e to the minus x is 2e to the minus x. So that is correct. Next problem, the integral from 0 to 10, absolute value of x minus, nah, that's not it. Absolute value of 2 minus x dx. Again, the easiest way to do this is with simple geometry. Or you use your calculator, plug in the function in your calculator, do it with your calculator. Then you are here at 2, and at 10 we are here at 8. So the first area is a triangle of height 2 and length 2. So it's 1/2 base times height, plus the next triangle here, it's 1/2, the base has length 8 and the height is 8. So that is the same then as 2 plus 32, which is 34. Okay, now finally again, a u substitution, the antiderivative of c squared times the square root of c minus 2 dc. And if you write this again in power notation, it's the antiderivative of c squared times c minus 2 to the 1/2 dc. So what are the choices for u? You could take u equal to c minus 2 or u equal to c squared. Any of the choices is correct if you want. If you choose u equal to c squared, then this is not good, and I know it's not good because I've done this a few times in my life, but if you choose it, let's finish it anyway. Then you will have du dc is equal to 2c. And if you solve this for c, then you get c equal to the square root of u. Assuming that u is positive. Okay, now if you plug this in, so c squared is u, c is the square root of u, and what is dc? dc is one over 2c du is equal to dc, and c is equal to the square root of u, so you have 1 over 2 square root of u du is equal to dc. So you get here times 1 over 2 square root of u du. So this is the same as the square root of u minus 2 to the 1/2. U over the square root of u, you have 1/2 square root of u du. So everything is correct. This integral here is the same as this integral here. You didn't make a mistake, except that you started with a bad integral and you ended up with an integral that is even worse. So that means the u substitution did not simplify the problem, it made it more complicated. So let's try it again. And now this time let's pick u equal to c minus 2. then du dc is equal to 1, or du is equal to dc. And if you solve this, then you get c is equal to u plus 2. So if I substitute this information in, then this integral becomes c is u plus 2 squared times the square root of u du. And that is now something that can be simplified. It's the antiderivative of u squared plus 4u plus 4 times the square root of u du, which is the same as the integral u to the 5/2 plus 4u to the 3/2 plus 4u to the 1/2 du, which is u to the 7/2, 2/7, u to the 5/2, 2/5, plus 4u to the 3/2, 2/3, plus a constant. So which is then 2/7 the square root of c minus 2 to the 7 plus 8/5 c minus 2 to the 5 the square root plus 8/3 square root c minus 2 to the 3 plus a constant. So that is now the solution. So in this case, the u substitution again transforms it into a complicated integral. But by shifting the -2 to a +2 over there, you can then multiply it out and it becomes doable. Now comes a trick problem. Yeah, e is a number, it's a constant. Now wait, that is wrong. That was here. dt. So the variable here is t, not x. The variable is t, and the antiderivative of a constant with respect to t is e times t, not e to the t. The derivative of e to the t is e to the t. The derivative of e times t is e, where you plug in -1 and x. So it's ex minus e, or it is e times x minus 1. That's maybe the hardest problem, even though it's the easiest problem. But certainly the hardest problem is there. We would expect that without being warned, 50% of the class gets these types of problems wrong. Okay, an easier one, standard one, integral 1 over 2x logarithm of x dx. Now, what could you, there is nothing to simplify. It is what it is. So you could choose u equal to x. That's not good. It really doesn't change. It just makes it the integral 1 over 2u logarithm of u du. So that is not a good choice. You could take u equal to x log x. That's a really bad choice, because then du is, what is du? It's then the logarithm of x plus 1. And I cannot solve this for x, so u equal to x log x, I cannot solve it for x. Yeah. So this doesn't work at all. I wouldn't even know how to substitute it in. If I substitute this in now, then I would get the integral 1 over 2u. Now what is dx? 1 over logarithm of x plus 1 du. But now I still have an x here. And I do not know how to get rid of this. Huh? I cannot use this to get rid of this. So now I end up with an integral that is not fish and not meat, because you have a u in there and still an x in there. So this just does not work at all. So the only other choice is by exclusion is you take u equal to the logarithm of x, then du dx is 1 over x, or du is 1, du is 1 over x dx, and if you plug this in, then you have integral of 1/2, so that's the 1/2 here. Then you have logarithm of x is u, and the 1 over x dx is du, which is then the same as 1/2 the logarithm of u plus a constant. So it is 1/2 the logarithm of x plus a constant. Again, I will post these notes after the class, so we can look at it again. And also when you do the homework problems, you will see that there are many similar problems like this in section 5.5. Here is a standard one. So there is a clear insight. You take u equal to 2 pi x. Then du dx is 2 pi, or 1 over 2 pi du is equal to dx. And if you substitute this in, then this becomes the antiderivative of 9 cosine u, and dx is 1 over 2 pi du. So it's 9 over 2 pi. The antiderivative of the cosine is the sine of u plus a constant. So this is the 9 over 2 pi sine of 2 pi x plus a constant. And now you check again that the derivative of this is equal to what you started with. Okay, now an important problem. So if you have an odd function, then the integral from minus a to a of f of x dx is equal to 0. You can prove this with u substitution or by a picture. If a function is odd, that's maybe not a good odd function. That means it's symmetric to the origin. How hard can it be? Meaning that this area is the same as this area, just that they have different sizes. Yeah? So the total area, the net area, is equal to 0. And the other remark is that if f is even, then you have that the integral from minus a to a of f of x dx is 2 times the integral from 0 to a of f of x dx. And that is a significant simplification, because sometimes it's easier to plug in 0 in a in the antiderivative than to plug in minus a in the antiderivative. Okay, so these are 2 things which I would recommend that you write on your cheat sheet. And then with this comments, the next problem is now easy. If you have the integral from minus pi to pi of sine of x over 1 plus x squared dx. So whenever you see minus a to a, then you should see, does it have something to do with this remark? In this case, you can easily see that the sine of x is an odd function. 1 plus x squared is an even function, which is then odd divided by even is an odd function. And by the remark above, this is equal to 0. So if you know this, then this is very easy. If you try to do this with antiderivative or U substitution, you might as well shoot yourself. Impossible. Okay, now one last 3 more problems. So let's do the integral, the antiderivative of x over x squared plus 1 dx. Again, if you rewrite it, it's x times x squared plus 1 to the minus 1 dx, which indicates that you might u as to be the inside, u is equal to x squared plus 1, and then du dx is 2x, or x dx is 1/2 du. And if I plug this in, then this becomes x dx is 1/2 du, 1 over u du. So it's 1/2 the logarithm of u plus a constant, which is 1/2 the logarithm of x squared plus 1 plus a constant. But you can also drop the absolute value sign, because x squared plus 1 is always positive. Let's do the integral from 0 to a of t squared plus 1 squared dt. Now there you can try u substitution as long as you want, it will never work. So whatever you do, the integral will become more complicated, yeah, and never easier. So what would be a typical u substitution? U equal to t squared plus 1. Or if you solve this for t, is then the square root of u minus 1. And we have du dt is equal to 2t or 1 over 2t du is equal to dt, or 1 over 2 square root of u minus 1 du is equal to dt. And if I substitute this all in, then it's the integral from 1, if I plug in 0, to a squared plus 1 of u squared, and dt is 1 over 2 square root of u minus 1 du. So it is the integral of 1 to a squared plus 1 of u squared over 2 square root of u minus 1 du. So that is perfectly okay. You will get 8 out of 10 points because you did something that is right. You did a perfect u substitution. Unfortunately, it didn't simplify your problem. It complicated it. You transformed the integral into an even more complicated integral. So the real way to do this is then just by asking yourself, can I simplify this? And yes, you can, because the integral from 0 to a of t squared plus 1 squared dt is the same as the integral from 0 to a of t to the 4 plus t squared plus 1 dt, which is the same as 1/5 a to the 5 plus 2/3 a to the 3 plus a. Okay. Now, one last problem. It's one of the bonus problems. If you have that the integral from 0 to 1 of f of x dx is equal to 10, what can you tell me then about the integral from 0 to 1 of x to the 3 f of x to the 4 dx? Now that is an easy u substitution where you take u equal to x to the 4. Then du is 4x to the 3 dx. Or you have 1/4 du is equal to x to the 3 dx. And if you substitute this in, if x is 0, u is 0. If x is 1, u is 1. And then you get 1/4 f of u du, which is 1/4 integral 0 to 1 f of u du. But now you know that the area under the curve is 10, and so you have this is then 2